Hi, my name's Ivin Lam, and today I'm going to show you what the system and surroundings is, as well as how we can apply it to chemistry. So I went to go get some hot chocolate, but it was way too hot for me, so I decided to go on a short walk so that it would cool off a bit. But when I got back to my door, my hot chocolate turned into cold chocolate. Some of the heat had disappeared, but where? Well, we know that the heat didn't just disappear. Heat is a form of energy, and according to the first law of thermodynamics, energy cannot be created or destroyed, only transferred. So where'd it go to? It transfers to what chemistry calls the system and the surroundings. The system is the specific set of chemicals, substances, or reactions that we're currently looking at, while our surroundings consist of literally everything else that we're not focused on. And so in this case, our system would be the hot chocolate in its liquid state inside the cup, while our surroundings are everything else, including the cup itself, the air around it, and some random animal you found outside. Since energy can only be transferred, anything lost by the system must go to the surroundings and vice versa. And this leads us to three different types of systems: an open system, a closed system, and an isolated system.
An open system is any system that allows mass and energy to be exchanged with the surroundings. This is like me boiling a pot of water. Not only can heat be exchanged with the surroundings, but also the water vapor being produced. A closed system is any system that allows energy to exchange with the surroundings, but not mass. This would be like me putting a lid on this boiling pot of water. Heat is still able to go into the surroundings, but not the water vapor being produced.
An isolated system doesn't allow any transfer into the surroundings. This would be like putting insulation around a boiling pot of water. No mass or energy goes in or out. But how does this tie into my hot chocolate becoming cold? Let's analyze the scenario. The heat that we were focused on in our system was the heat from our hot chocolate. Our hot chocolate's cup has a lid, but it doesn't have any insulation, meaning that we can safely assume that this is a closed system. A closed system will allow energy to go in and out of it, but not its mass. So since now our liquid is at room temperature, we can safely assume that our system disposed of its heat into the surroundings. As a result of this, we call this an exothermic process, which allows heat to go from the system to the surrounding area. When the opposite is true, and the heat goes into the system from the surroundings, we call this an endothermic process. Knowing these concepts, we can mathematically determine the change of energy in a system through this equation, where delta U is internal energy and subscripts F and I are final and initial states respectively.